In this next talk, we'll address quantum cybersecurity in the context of a classical environment. By classical environment, what we mean here is classical internet, classical communications and computation. So, first of all, it's important to recover the two concepts from intelligence studies and strategic studies, Yonin and Inin, from the Japanese classics, where the Yonin and recovering the concept is the use of disguises and the building of undercover networks of operatives, which are used to obtain intelligence, strategic intelligence, and to disrupt the target. And a good example being the spreading of fake rumors, psychological operations, and so on, subversion. The Inin is infiltration using stealth to break into a castle or enemy camp, was in Japan's medieval context, using stealth to break into a castle or enemy camp to obtain strategic and tactical intelligence and to disrupt that target, included setting fires. In the cyber context and in 21st century cyber context, we also have cyber Yonin and cyber Inin. Cyber Yonin is the online management of fake accounts for hacking and psychological operations, as well as the use of undercover operatives to hack computer systems and networks. So it still involves the use of disguises and undercover operatives. Cyber Inin is the breaking into computer systems and networks without being discovered. And it's important to state that these two are interconnected. And that we cannot evaluate the probability, for instance, of a hack to occur without considering the strategies and tactics that hackers, state-sponsored or not, that hackers can implement in order to penetrate the system. And this can include Yonin activities and Inin activities conjointly with technological innovation. And it's here that the quantum enters into play. So quantum computers, we are not there yet, but we are approaching it fast. Quantum computers in the near future may be able to be used as a sort of digital lockpick. And this is one of the first major applications of quantum computers in cyber attacks. And one of the major first areas of research in quantum cybersecurity. So the main issue is that quantum computers can be cyber-Inin tools. By cyber-Inin, of course, we mean breaking into computer systems and networks without being discovered. In this case, the traditional lockpick used to break into a place, it's this idea that carries over to the context of cryptography. And the idea is that quantum computers can be used as a sort of digital lockpick that open a locked secret. This is a good image to express this main application. The target is a classical cryptographic system. So we have quantum attacking classic. This has led to a new field of study, which is post-quantum cryptography. It's a response against the possibility of quantum computers being used to break into public key cryptography solutions. And it's a new research field, a booming research field. And the National Institute of Standards and Technology has been pushing forward this research field. So post-quantum cryptography, and this is already one result, and it's taken from the National Institute of Standards and Technology, says that in recent years there has been a substantial amount of research on quantum computers. And this idea is that this constitutes a threat for cybersecurity in the sense that quantum computers are becoming increasingly more powerful and feasible as tools that may exploit classical crypto systems and attack them. So the main issue is how to be resilient against an attack from a quantum computer. And we have here that one of the main issues why quantum computers can be used for this is that they can be used to solve mathematical problems that are difficult or intractable for conventional computers. And large-scale quantum computers, once built and feasible, they will be able to break many of the public crypto systems currently in use. And this is a problem for not only for countries and for the area of defense and security, countries' defense and security, national security, for instance, protecting state secrets. It's also important for online business. It's important for banking. The global economy depends upon public key cryptography for many transactions. And the problem here is that an attack by a quantum computer would be problematic for these companies. It's also an interesting issue regarding blockchain and cryptocurrency, because fintech has boomed and cryptocurrency has emerged as a major global financial asset, with being used in transactions, both of the normal economy and the underground economy. And we have a global economy supporting, for instance, cryptocurrencies like Bitcoin. But Bitcoin and these cryptocurrencies rely on cryptography and blockchain. And one of the major issues is the resilience of the blockchain against a hacking. But the issue is quantum computers. How could quantum computers be used to hack a blockchain or for mining Bitcoin, for instance, and the contexts and the consequences that this could have for a financial system that has integrated and deepened the crypto, in this case cryptocurrencies, in their global transactions. Many investment funds are investing in cryptocurrency, heavily investing in cryptocurrencies, and fintech is here to stay and will only expand and deepen, so becoming normalized. This is a major issue, and we need to develop solutions against attacks from quantum computers. And this is the field of post-quantum cryptography. The second report is from the National Institute of Standards and Technology, which can be found at this link, is the second report from 2020, already contains the results of the most recent research done into post-quantum cryptography. One issue that is raised is that new public key cryptography standards will need to be put into place, and this is the major issue for this line of research, to be resilient against an attack from a quantum computer. So they will have to specify, one of the recommendations is that they will have to specify one or more additional digital signatures, public key encryption, and key establishment algorithms. And the recommendation is for a pairwise key establishment schemes in using discrete logarithm cryptography, and integer factorization cryptography. These algorithms are intended are aimed at protecting sensitive information, protecting the systems against attacks of quantum computers. They may become even more resilient against attacks from classical computers as well. So these revisions to public key cryptography standards, we can expect an evolution here as well in terms of research, growing research and test drives of against regarding an attack from a quantum computer on a cryptographic system. So we can expect simulations of this and tests as quantum computers become more powerful. We can expect that some of these standards may be reviewed, issues of how to attack these systems and how to defend. And this is one of the open fields of research that has seen advancements recently. And this is one of the example of an advancement in terms of this initiative. Another issue that is raised about cryptography and about access to restricted systems, an issue that that is important to consider, regards, for instance, biometrics. So we can enhance our access using biometrics as well. But the issue is that quantum computers may also become an important tool in countering biometrics, biometrics security systems. For instance, the creation of fake biometric using advanced machine learning, quantum machine learning, might be a future issue, but this is still very on the early stages, and we cannot say for sure how that could be done. But it's one of the possible future issues that should be researched upon. Another issue is still about quantum artificial intelligence, and this is very important, is AI hackers. And we are already seeing AI used in hacking. But this is another example of cyber inning, and it's linked to hacking automation. And the disruptive point here is the employment of quantum AI solutions to enhance AI hacking tools, or even to introduce hacking bots, artificial intelligences that break into systems. So this is a more advanced level of cyber weapons. Artificially intelligent cyber weapons is already a more advanced level of cybersecurity using classical AI, and quantum AI may even enhance this further. And this is another open issue in terms of investigation. This is uncharted territories. Mostly of this research that we're talking about in this talk are major hot topics of research, and where there's much to be done. One of the issue is of AI hackers, and Bruce Schneier wrote an interesting article on the coming AI hackers, and he talks about two uses of AIs in hacking. AIs used to hack us, that is, hack our behavior, and modify our behavior. So hacking, this idea of hacking is to modify the behavior of a system, either improving it or disrupting it. That's the idea of hacking. For instance, I can have a computer and the idea of, or a code, and I can hack it in the sense of improving it, an algorithm, for instance. But the idea of illicit hacking, where there's the penetration of a system to which I should not have access, to disrupt that system, is the idea of hacking linked to cybersecurity and cyber threats. So, but the issue of cyber psychological operations is that AIs can be used to hack our behavior. And we are increasingly being hacked in the legal sense, not the illegal sense, but the legal sense, by algorithms immersed into social media, recommendation engines that create vast echo chambers. So this is AI being used. These AIs are already modifying our behavior. We are adapting to the other people's responses on social media, but also to how, and the AI is learning about our interaction and responding to our interaction. And we have this feedback between people and artificial intelligence systems in Netflix, in YouTube, in Facebook, Twitter, and so on. And these AIs affect our behavior, and they can be exploited. These algorithms can be exploited and are exploited in cyber psychological operations to create viral dispersions of fake news, for instance, of fake contents, of rumors, or even of true information that is leaked, a scandal, for instance, and that undermines, can be used to undermine countries, governments, for instance, or even a company. So these algorithms can be used to hack us, and hackers can hack us using, for instance, troll bots, fake social media accounts that are managed by bots that disperse fake content, for instance. So these are AIs used to manipulate. With the deep knowledge of how the algorithm is built, we can disperse content in such a way and create content automatically using AI to make the algorithm select that content to show people. And this affects people's behavior. So we have here AI used to hack us. And this is a cybersecurity problem, and which has cultural dimensions, social dimensions, has interdisciplinary bearings, and we need to consider it. The other idea is the AI becoming hackers themselves. That's another idea that is discussed in this article. And it's an interesting idea because it leads to the most advanced level of cyber weapons, which is artificially intelligent cyber weapons. So how can AIs be used to hack us? Smart hacking tools used to find vulnerabilities in systems, to break into systems as advanced as cyber weapons and to hide the hack. An example of what was an advanced cyber weapon was Stuxnet, to disrupt physical systems. AI and robotics algorithms used to and exploited to influence human behavior. This is a PsyOps, psychological operations, and the cyber psychological operations tool or weapon. And it's possible to take advantage of the knowledge of algorithms incorporated in social media to get some content to be selected in cyber psychological operations. So these were the few points that we discussed. So hacking social media, let's look at this a bit more, and then how the quantum can be used to exploit this. Hacking social media, it corresponds to cyber yonin, not in-nin, not breaking into a system stealthily, avoiding to be detected. It's cyber yonin, it's using of online disguises, it's creating networks of fake accounts, some of them linked to legitimate accounts, learning how the social media algorithms select content to be shown in feeds, for instance, and exploiting these algorithms for a specific content to become trending and possibly viral. So how can I design content so that it becomes viral? And this enhanced content design can be enhanced by algorithms that evaluate big data from users, from social media users, and see how to design a message, certain content to reach a certain audience, and so that it may be selected by the social media own incorporated artificial intelligence systems for content selections, the recommendation engines, and so on. So this is a main issue. For instance, in Twitter, we can use example of how one can build a Twitter exploit. One can tweet on trending topics and hashtags and use the hashtags, which is a piece of cybertextual communication, which is a new cultural dimension added by social media. So we can tweet on trending topics and hashtags, incorporate hashtags smartly into text, create a message that evokes emotional responses in people, incorporate, if possible, images, emoticons, videos, or GIFs, or GIFs, depending on how you prefer to pronounce that word. Use message design for emotional response on the part of the audience, use hashtags that are retweeted by bots. So I may not control those bots, but if I use a hashtag that is retweeted by specific bots that retweet anything that contains the word artificial intelligence, they start retweeting these tweets. So I'm exploiting these bot accounts that I do not own, that I'm not manipulating, but I can use them. So this is a Twitter exploit that exploits not only the social media's algorithms for selecting the most important tweets, it's also manipulating people's behavior and bot automated accounts that retweet on specific hashtags, for instance, or keywords. The use of network of fake accounts and bots to disperse content using troll bots to enhance impact. So this is a Twitter exploit and anyone can use it. And this is the scary point. Anyone can do this. A single individual or a group of individuals, non-state sponsored, can become viral and affect a country, and affect governance, affect a company, for instance. So it's a widespread point. Even target a single individual. It would be considered then a cyberbullying. So defenses against social media fake content operations. We'll see more, and even how quantum, when we in the final talk, we'll see how the quantum can be used as a defense against this, as well as an attack tool, but also as a defense. Defenses against social media fake content operations. There are some cyber defenses. For instance, automation of fake content identification using machine learning tools. So, for instance, if I have neural networks that try to scan through, or machine learning algorithms that scan through text and image and try to identify fake content online, and be used as a tool to reduce fake content in social media. Crowdsourcing of fake content identification. This is using volunteers. Twitter has recently added a feature. For instance, if you retweet an article, it gives you the option, it recommends that you read the article before, and if not to click automatically. If you click on the first link, on the first marker that appears when you try to retweet, it will immediately take you to the article. This is to foster some reflection on the part of people, not to retweet automatically. So if they retweet something, they should read what is there and reflect upon it. So this is an educational dimension. But in terms of cyber solutions, these two, automation of fake content identification using machine learning tools and crowdsourcing of fake content identification using volunteers and even AI in combination, these are cyber defenses against social media fake content operations. So now we, having established the few points about the classical side, let's go to the quantum side of things. How can we design a message for impact and in terms of algorithm and the target audience? All this can be enhanced by AI systems. So we can develop algorithms for learning how to design a message for impact, taking into account a target audience, and we can use AI to enhance this. And for this, we need big data, social media big data, and machine learning. This is where quantum machine learning enters into play. And with the advent of quantum machine learning, if the accelerating of machine learning algorithms is achieved, so that it surpasses classical machine learning, then working with big data and finding new hacking algorithms using quantum machine learning, assuming that it surpasses classical machine learning or even accelerates classical machine learning algorithms, then this will be it will become easier to find new hacking algorithms, new hacking AI systems to break into systems, new algorithms for social media manipulation, but also new algorithms for cyber defense, for identifying intrusions, as well as to identify fake content online, for instance. So mainly state-sponsored operations will, the first type of researchers or of people who will have access to this type of technologies will be for sure state-sponsored states that have a big budget, and some companies, for instance, defense contractors, cybersecurity companies working with states. So in principle, quantum machine learning used as advanced cyber weapons will first be seen in most probably in state-sponsored operations, but also with users that can access quantum computing resources via cloud-based access. But here it's less likely to be in a short term. It's less likely that they'll be able to employ this in cyber warfare in the short term. In principle, only people with large budgets will be able to do this. Either criminal organizations sufficiently advanced in terms of technological power, but this is in the medium to long term, mostly long term. But first we'll see this in states. So quantum fake content design, that is quantum computers used for cyber psychological operations. Here we have a new area of research, also not only for used for cyber psychological operations, but also to defend against cyber psychological operations or against fake content design. This is a field of quantum generative adversarial networks. So we're dealing with here, we're dealing here with quantum artificial neural networks. This may become the next step in fake content design, but also in fake content discrimination, that is the cyber psychological weapons tool, a weapon tool can also be used as a PSYOPs defense tool. So the tool that is used as a weapon can also be used as a defense for automated fake content identification. The difference will be in terms of who has the best training data, algorithms, and quantum resources. Access to quantum resources. Why is this so? Here we have to take into account what are generative adversarial networks, how they function. So a generative adversarial network, or a GAN scheme, is basically we have a generator network that generates fake samples, and a discriminator network that is trained on fake samples and true samples. And the discriminator network tries to distinguish between true and fake samples. So this is trained in discriminating true from fake, and this one is trained conjointly, they are trained conjointly into generating increasingly more fake samples that are increasingly difficult to distinguish from true samples. At the end, we may have a generator, a very powerful generator network, and a very powerful discriminator network. So this is the GAN scheme, the generative adversarial network. So, we already have a gigantic amount of research into GANs, and they have already been used to create fake accounts. One that I'm speaking out of memory was a LinkedIn account that had an image generated. The image was AI generated, and it was a fake picture of a woman who, in the account, was being managed as a spy account. It was uncovered eventually. This is LUniv, and was able to connect to major players in Washington. So this was a LinkedIn account, and the image was fake. It was found out that the image was produced by an artificial intelligence. So we have here the generative adversarial networks are major tools in the generation of fake images. So here we have an article that addresses this new area of research, but from the perspective of quantum technologies, and we are already seeing research into quantum generative adversarial networks for image generation, so for fake image generation too. In this example that is taken from this article, they say that they devise a flexible quantum GAN scheme to narrow the knowledge gap, which could accomplish image generation with arbitrarily high dimensional features, and could also take advantage of quantum superposition to train multiple examples in parallel. So this is a major issue. The possibility of using quantum superposition to accelerate and even enhance the training of quantum generative adversarial networks, and this could be, this quantum acceleration can produce an enhanced way, enhanced fake image, fake video. So we the possibility of future quantum deep fakes is an effective problem from cybersecurity perspective, but also it can be used for defense. So these quantum generative adversarial networks, if they become more efficient and effective than classical, their classical counterparts, then they can have an advantage over in defense against fake content produced by the classical counterparts if employed as fake content finders. So this is the defense side. This is the security side. But we also have the other side, the dark side, which is in this case was painted in red. If quantum GAN solutions become more efficient and effective than classical GANs, they can be deployed as more efficient and effective producers of fake content. And here we'll need to move to quantum generative adversarial networks as a cybersecurity response. So not only to find the fake, but also many players will move to the quantum to produce the fake. So this is the future of quantum generative adversarial networks. The research is now starting, and it can, as it becomes increasingly feasible and access to quantum resources become increasingly feasible, we'll see this being simulations on actual quantum computers of quantum generative adversarial networks. Regarding AI hackers, this is the next level. So far I've talked about AI hacking tools, so AI used in hacking. The other level is AI hackers, that is AI used as hackers, hacking automation, where an artificial intelligence is trying to find vulnerabilities and hack systems. Classical research into this is new, is a new field, growing field. But we'll see also the quantum side in a few years, inevitably. So an example of this is DARPA's Cyber Grant Challenge, which is an AI hacker challenge. And after completion of qualifying rounds, several there are a few, we'll see who wins the challenge. And here AIs were given 10 hours to find vulnerabilities. So that's what a hacker needs, and that's what a hacker does. Find vulnerabilities to exploit against other AIs in the competition who patch themselves against exploitation. So this leads to several levels. AIs used to hack cyber systems, AIs used to hack other AIs and modify their behavior. And that's a major issue, because as automation becomes increasingly integrated into the fourth industrial revolution, cyber physical cognitive systems. So we have the merge of the robotics, the physical, the devices, the cyber, the internet, and the cognitive, which is the AI dimension. And this is the great driver of the fourth industrial revolution, this merge between information and communication technologies, artificial intelligence, internet, and physical devices. So as this becomes increasingly more feasible, more deepened, the AIs can be used. The issue of AIs used to hack, or algorithms used in general to hack an AI, to modify an AI's behavior, may have serious consequences because it will change how smart devices respond. And this can have disastrous consequences if these smart systems are managing physical systems. They can produce disasters and so on. They can also be used to change the behavior of algorithms. For instance, if a social media account's algorithms are hacked and the recommendation engines are hacked, it can also produce biases and influence people's behaviors. So this is a major issue. And of course, this opens the question of quantum machine learning. So quantum machine learning, both for defending, and here we have the main point: defense, patch themselves against exploitation, adapt to a hacker, an AI. We can integrate. We can also the implication of this statement that is in red also means that an AI can be used to create an artificial immune system, and there are already cyber solutions in terms of artificial immune systems as a possibility, and artificial immune systems, intelligent immune systems, artificially intelligent immune systems, integrated in cyber systems, to identify threats, to identify a hack if it occurs, anomalies, and respond to those anomalies. And this is the level of defense of cybersecurity that is key for companies, for governments, and so on. And this is another hot area of research and application of AI. So here we have, and machine learning. So here we have the issue of quantum machine learning impacting all this. And there are three research directions with impact in cybersecurity. Classical machine learning algorithms running on quantum computers for acceleration, quantum machine learning algorithms running on quantum computers, and quantum-inspired machine learning algorithms running on classical or quantum computers. These are three areas of research into quantum machine learning that are currently developed in most different applications, and that will see a rise in the future with the quantum machine learning revolution. And anyone who researches into this area with producing good results will most certainly have an impact in terms of technologies, business, and so on. This is the quantum machine learning revolution. The other level is the quantum internet. The development of quantum communications marks another level of cybersecurity that is even more transformative than quantum resources applied to classical internet. And this is our next level, and our next stop in these talks on quantum cybersecurity, which is quantum cybersecurity in a quantum environment. So that's all for this one. Next will come the following.